I'm from Spain. That's why my accent is so weird. So I only have 20 minutes to speak here. It's like a super fast track. But I want to say something about the awesomeness of Spain. Just to go to Spain. We are like the inventors of one of the kinds of yoga that is most known in the world. It's called siesta. It's the best kind of yoga you can ever have. And of course, we are world champions, the soccer world champions. So I know that in the last year, in the last World Cup, we were not doing like pretty well. But even though we won the champion, I'm only going to say 3 things. Okay, only 3 things about Spain because, as I said, it's I don't have so much time. So siesta is one of them, and Spanish soccer championship is the other one. Oh wait, I said the third one. Okay, wait. Careto is a Spanish malware too, so I think that we are doing pretty well in my country. Okay, cool. So let's start about this speech. So it was a while ago. I was doing a pen test, and I work in a red team. So we do all this kind of physical stuff. We do phishing campaigns. We just get sell and go from there up to the databases or so on. So I went to this company. We were pen testing. What? It's fine. Yeah, it's fine. Thanks. So yeah, I went to that company. I had a pump log. I installed a pump log in the company. I get away, but unfortunately, we were in a VLAN without any access. I think it was like the phone VLAN, so it was kind of useless. And the only device that we were looking at from that pump log was like our target today. It was a Meraki device. Meraki it's a company that was acquired by Cisco some years ago, and that was like the actual panel, you know, the web panel that they had with some information about, some information about the device, IP, and blah blah blah, like the normal stuff. You know, typical auth to access to some configuration, but the thing is that this was a security appliance, okay? That piece of hardware was in charge of like doing all the security filtering and so on. It was like layer 7 application visibility, IPS, antivirus, anti-phishing, I don't know how that works, stateful firewall, so on. And it cost around like $16,000 to like $32,000. So they are like a pretty expensive guys. So yeah, this is the device. You can see it here. It has on the left, it has a hard drive, the microprocessor is over there, and blah blah blah. Okay. So what I did, it's going to Cisco, and because I'm a very kind person, I asked them to get one of those devices because I was doing a security review, and after that, maybe we will buy tons of those products to you, Cisco, because you are so awesome. So they gave me one of those appliances. So the first thing I did once I had it was just using the screwdriver and open it up. It turns that it has a 1 terabyte hard drive, but it's only used for some like cache functionality, historical stats, but the OS is not there and the file system is not there, unfortunately. So move on. After that, maybe I'm not very good with all this hardware stuff, but I really love it. I really love like dumping firmware, analyzing it, and just finding the pinouts and reading data sets to know how to interact with it. So what I tried is finding those pinouts, and finally I found that there was a serial pinout over there, just sitting there for me to interact with. So yeah, I was playing with the baud rate, and after all, I found the correct baud rate and the correct pinout. So if you can see here, it's a U-boot, so it's the bootloader and everything. I was able to get a cell. It was a root cell. This is the device when I open it up. Here it's the Raspberry Pi. I connected to the serial pinout in the motherboard, and it was connected to a switch, and I was connected to that Raspberry Pi. So at the end, I was executing commands. It gave me a cell as root. So okay, first thing was okay. I had my physical device, I had a root cell, and I have to start like going through all the configuration files to find, I don't know, like the typical hardcode passwords or like some bypass stuff to get the control after that in the real pen test of the actual company I was doing the pen testing to, okay? So, first thing, if you get into a Linux system, what are you going to go after on your root? Typical sudo, the password, right? In this case, it was in password, etc password. The hashes were there. It was the root, nobody, Meraki, and MF, okay? But as you can see, the only one that has a proper cell is root. I don't know if you can see it, it's bin ash. It's not bin bash, but it's like that minimal shell. But the rest of them have like login check, MF login check, or bin false. So actually it was kind of useless. I was not able to use those users to get a cell into the system. Yeah, one thing I didn't say is that if you nmap this device, you could see that it's listening to port 22. It has a SSH server over there listening for you. So the first thought I had is, okay, maybe I get some user from here, I crack the hash, boom, SSH into it. But no luck. The other thing I was looking for, it was the HTTP auth hashes. So there is a light HTTPD running on the device, serving like websites, the web pages, and there is some auth, as you could see, like in the third or fourth slide. And here we can see hashes. And actually, I was able to crack MF test. It was not very difficult because the actual is MF test too. So it's a thing. Once I got it, I was able to access to those like configuration things through the web interface. But it wasn't very helpful, to be honest. And last thing I did is just listening all ports and service to know if there is something interesting over there. There was a couple of C listeners listening there, so maybe something interesting to watch out. But I was after CGIs. It's like typical thing when you're like doing reversing in a router or something, doing an assessment, is going to CGIs. It was a light HTTPD, listening to the port 80, as I said, and there was a couple of big binaries that were holding all the CGIs that the application was going to use. And those are the names of them. One of them is stats. It's in the path stats, and it's called ps.cgi. I don't know. The other one was run_cell.cgi. And the other one here is row upgrade.cgi. So, I don't know. That was shocking for me. How can it be like runcell.cgi? That was my face at that moment. What was that? So I just started looking at PS. PS just did what it is, a PS in the system. And so the output in the browser. Okay, that was like super straightforward. What's the thing? That Meraki uses a token to communicate, because the Meraki devices, the cool thing that they have is that they connect to the cloud. So you can control and you can configure all your devices through the cloud. So you don't need to go to the internal LAN and connect to the device and do the configuration and so on with all the devices independently. You can just go to the cloud and you will have all the list of all your devices and you can configure them. That's pretty cool, actually. It's a good thing. But all the devices need a token to speak with the cloud. So doing a PS, we were able to list this mTunnel client with the key. So that's the token that is used by the device to speak with the cloud and say, hey, I'm the guy that I'm supposed to be. So first thing that we get is that key. So now we are able to speak with the cloud and spoof data in the cloud. We can say, yeah, I'm like in a critical situation, I need somebody to check it out, or like everything is okay, there is no intrusion here, everything is fine. So we can send those kind of commands to the cloud, so no alarm will be triggered. So that's something interesting I found there. Okay, the other thing I went for was like getting the firmware. In this case, it's not like in all the D-Link or other vendors that they publish the firmware and you can download it without having any further like license. But for Meraki it's different. Actually, because all these devices are connected to the cloud, they are able to download the firmware and doing like an automatic update. You don't need to download the firmware, go into the web interface, browse like the specific firmware and update it. You don't need to do that. Meraki does it for you. That's a cool thing too, because you're up to date normally. But I was able, actually, it was like kind of weird. I was playing with it. I didn't have connected this device to the cloud because to the network, because I knew that these devices were going to connect to the Meraki cloud. But finally, I connected to it, and the device got like a update.sh into the system, and in that update.sh, I was able to find this link. Oops. Firmware.meraki.net, blah, 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 blah. And they were like asking for a MAC, for a key, and for the desired version. In this case, you can see it's wired PowerPC. The device I was using was a PowerPC microprocessor architecture. A pain in the ass. We will see later. The cool thing is that they were not checking for that MAC and key. So you can just like empty MAC, empty key, and just ask for the version that you want from the firmware, and it will work. Okay, they fix it. Now you need that pair. Yeah, that's like a configuration where you can see how they are getting that key. They are just using the serial number of the device and hard coding some strings and doing a SA1. That's it. Okay, so wait. I can access to a specific version. As you can see here, we say, I want the version 12.43.31. Okay? So it was a sequential ID. So I was able to fuzz it, and I got even firmware that was not published yet. Not published, it was published because it was in this website, in the firmware website, the server, but it was not actively being used by the Meraki clients. So, by the Meraki servers, I mean. So I got around like 1.5 GB of firmwares, and I can work with that. I just did a script to go through every ID and download it. And this is my favorite one. Okay, run cell.cgi. It's an auth, so we don't need even to have that mf_test credential that we got before, cracking the hashes. So if we access to it, it says unknown error bad key. If we just do a GET request to it, that's what it says. So because I thought it was like super interesting, this CGI, I started debugging it. I mean, reversing the binaries and debugging it. But the architecture was PowerPC. I'm an IDA lover. I love IDA. I think it's one of the best tools ever. But IDA was not working properly, so I had to use GDB. The problem is that GDB was not in the machine, in the Meraki. But thankfully, GDB server was there. So they left GDB server to debug things in the production device. That was weird, but it was very helpful for me, very handy. So I was able to reverse it using GDB. And finally, I got this. This is what it is expecting. That's how they are signing all the commands you want to send to the device. You want to execute in the device. They are doing a SA1 of the Meraki serial number that's unique for each device. but I'm going to tell you it's very easy to get. The command that you want to execute, for example, like ls, and a fixed salt. The salt is the same salt for all the devices, all the different versions. So how to get the Meraki serial? Social engineering, just call Cisco. They are there to help you. So we just called Cisco, we checked in that company who was the administrator of the company. We said like, oh, I'm this guy, I'm blah, blah, blah. I lost my Cisco ID. Can you give it to me? I work for that company, blah, blah, blah. Yeah, of course. Cisco ID. And after some hours, we did another call. Hey, I'm this guy, this is my Cisco ID, but I can't access to my serial number. And they were super, super helpful. And they're like, yeah, of course. This is the serial number of your device. And because it's connected to the cloud, I know it. Because that's the cool thing about these devices. So now we have everything necessary to execute commands. So we needed like that key command, that is like all this thing, and this in CMD, and the CMD command is the actual command we want to execute, ls, for example. It took me a while using GDB and PowerPC, I don't know. Maybe you're used to the back PowerPC. I wasn't. It was my first time reversing a PowerPC architecture, so it was painful. But finally, I got it. Actually, as you can see here, this is on the left, you can see the serial number. In the middle is ls. And after that is to start like 501, and that's like the salt, like the fixed salt that they used. They do a SAWAN, and that's what they check. So, boom. We can execute arbitrary commands in that device. So at that point, I just came back to the actual pen test, and I started executing commands in the big team, in the company I was pen testing. I got a root cell in the device, and you can imagine, this is a security appliance. If you're rooting that device, you can do whatever you want. You can jump between VLANs, you can just pick up everything. We used like that was a DNS server too. So we were like playing with DNS, redirecting people to other places. It was pretty fun, actually. What I did was super easy, just dropping like the public key into that device and a reverse shell. Reverse SSH shell to my C2, and that's it. Another interesting thing is that when I spoke with the Cisco guys, they said, no, that's impossible. Yeah, there is no way to get SSH access to this device. Even we can't get SSH access to these devices. Like, come on, guys. Are you serious? You can't get access. You can't SSH into that device, but you have a SSH server listening there? Why? Anyway. But, as I told you, PowerPC sucks. It really sucks. Oops, 3 minutes. So, what I did, finally, I got the root cell, blah, blah, blah. But I was digging in this new system, in the actual company I was hacking, okay? I was pen testing. And it was, instead of being a PowerPC, it was a Intel 64 bits. We're like, shit, this is awesome. Yeah, thank you. So I tried to get the firmware for the 64-bit architecture Intel. I was so happy. I don't have a child. I don't know how it's having a child, but if I sometimes have a child, I think he will not give me the same amazing experience as I got when I finally got the 64-bit firmware. So what I did, typical thing, being woke was compressed. The format for the file system was CPIO, and I just decompress it. And finally here, you can see that I have access to the file system, being dev, root, typical file system in this kind of devices. So awesome, that was great. And this is the firmware for the 64-bit Intel version, I remember. Is that easy? It's just like that? It's not that easy, because we have the file system, we can execute some of the binaries that are there, but there was some tricky things that they were using, because instead of having all the CGIs independently, they were having all of them in the same binary, and they were using some tricky stuff. But what I did is just, okay, let's go to etc init.d, and there is a script that is called RCS. This is a script. It just go, in etc init, we can see we have S10 boot, S80 Meraki, S90 drop beer, blah, 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 blah. But what it's doing is just going through all of them and executing all of them. They're like the startup scripts. So I just did exactly the same. Yeah, I chroot everything to have it working, but I got tons of errors. But finally, after a lot of debugging, I was able to have my own Meraki in my Ubuntu machine without having any hardware and anything like that. So from here, it was super straightforward to reverse engineering the CGIs. Not only the CGIs, but all the services that we're listening to in that device, not only the CGIs. That's important because that's what I'm doing right now. 35 seconds. So yeah, here you can see, this is like, you can see it here, but this is the actual run cell. It's implemented here. You can see this is Intel 64-bit. So anyway, you can see it because it's very bad. And finally, this is the last thing, and I have still like 1 minute. It's called row upgrade. Yeah, that's 1 minute in Spain. Row upgrade, though CGI. So we got the credential. Come on. Okay.
Can you make it in 20 seconds?
So finally, 20 seconds. So finally, there was another CGI. It was called row upgrade. Thanks to that CGI, we were able to just push a modified version of the firmware that we got from the Meraki website, from the Meraki servers, and we were owning the actual. You were owning the server too. Cisco response was like bad at the beginning, but great at the end. So well done, Cisco. They filed 4 CVs. So really good. I don't know if ovnis exist. UFOs. UFO? Yeah, you say UFO. Yeah, that's my friend. He love it. I don't know if that's like something on purpose or not, but thank you, all of you, for
Alberto
listening
Garcia.
here.